Hey everyone, today we're going to go over what we're going to be doing on that very first day of welding. Please be sure that as I'm going through this, write down some of these notes. These notes I will expect for you to bring with you out into our lab while we're out there welding. These notes are going to contain simple things such as your amperage, what sort of rod should you be using, how many tacks you should have. So just simple stuff like that. So as I'm going through this, again, please write down some of these notes. If you need to get something to write with or something to write on, pause the video and go ahead and do that now. In addition, as I'm going through this PowerPoint, I am assuming that you have already taken your introduction to SMAW class. This is Advanced Shielded Metal Arc Welding, and so you should have taken that class prior to taking this one. And so a lot of this stuff will be more or less review, just so that we could all be on the same page. However, I'm not going to go back to the very basics of what stick welding is, so just keep that in mind as well. So let's move on here. Let's start with the polarity. Uh, in your intro class, you focused a little bit more on that welding aspect of things. In this class, it's going to get just a little bit more technical, a little bit more of a technicality of things, such as our polarity, for example, or learning what the numbers on the rods are, or even getting into more advanced things such as why cracks happen and things of that nature. But for now, let's not get too ahead of ourselves. Let's talk about polarity. And so when it comes to polarity, there's basically two different ways in which we could hook up to our welding machine. We have straight polarity, which you could see there on the left hand side, and then we have reverse polarity on the right hand side. Which one of these do we use? Kind of ask yourself that. And so when we're looking at straight polarity, we could see that our electrode holder is hooked up to the negative side, while our ground clamp is hooked up to the positive side. And as far as what our power source is, that's just our welding machine. So polarity just kind of explains how we hook up to our welding machine. And so if you had to guess again, which one or do we weld stick with typically? If you answered reverse polarity, you would be correct. Our electrode holder always goes hooked up to the positive end of that machine, and our ground clamp is always on the negative side. The most common way in which you will always see straight polarity being used is typically with the GTAW process. But when it comes to SMAW, we're always going to be using, or not always, but most of the time, we will be using reverse polarity. Now, one thing that you want to know when it comes to how your polarity is set up, whatever the positive end of that machine is hooked up to, that's where a lot of the heat will be concentrated at. And so, for example, right when you strike an arc with stick welding, you notice what happens right away. That electrode starts to melt, right? And that's how we're actually making that weld. And so we need that in order for that electrode to burn. As opposed to TIG welding, to where when you strike your arc, does that tungsten start to melt right away? No, right? It stays put. It gets very hot, but it never actually melts. And so if you'll notice that if you ever do hook up your leads incorrectly or on with the GTAW process and you strike your arc, then that tungsten will start melting right off the back. And so again, whatever's hooked up to the positive end of the machine, that's where most of your heat is concentrated. About 2/3 of the heat is concentrating, and the other 1/3 will be hooked up or will be concentrated on your base metal. So AWS electrode classification. How do we know what some of these numbers on the electrodes mean? And so, for example, here in this example, they have an E6010 rod. That's the proper name of a rod, and you'll see that stamped on the ends of your rod. Same thing with the E7018 rod. And so, what does it stand for? Well, the E simply stands for it's an electrode. Sometimes you'll see a numeration that starts with ER. That just means it's a filler rod. So, for example, if you ever look at a filler rod for the GTAW process, you'll notice it says ER in the beginning. Now, next up is our tensile strength. Now, this is in kilopounds. And so our tensile strength for a 6010 rod is 60,000 kilopounds. That's our tensile strength in terms of how much you could pull that metal until it breaks. And so that's what that represents. The one just simply represents in what position you could weld it on. If you see a 1, that's always going to mean that you could weld it in all different types of positions. And if you see a 2, it means it could be welded on flat and on horizontal as well. That last number just represents a type of coating. You don't have to memorize that, so you don't have to worry about that too much. However, just know that if a rod ends with an 8, for example 7018, that means it's a low hydrogen rod, which again, you could always refer to one of these charts. You could find these online anywhere, and we'll see here the digit 8 is a low high. Same thing with the 5 and the 6, however, you don't see those too much. So now to the nitty gritty here. What are we going to actually be working on in this class? In this class, you will be working on both open root bevel plate and also bevel plate with a backing strip, which again, you could clearly see that illustration there. The main difference between these two is that when you have a backing strip, again, I'm going to kind of highlight here on the PowerPoint, we have this backing strip right back there, right? We can clearly tell that this one doesn't have that. Not only that, but we actually have a gap in between these. And so when we're putting down our weld with an open root, we're basically just bridging the gap in between here. And then later on, I'll talk a little bit more about that. Probably about the second half of class, I'll have a whole presentation for you guys over open root bevel plate. But for now, let's worry a little bit more about this backing strip. So now talking about our bevel plate positions, they might be a little new to you. I know when you were in your intro class, you welded on 1F, 2F, 3F, and 4F. In this class, very similar. You have 1G, 2G, 3G, and 4G. The G just simply stands for a groove weld, because we're not going to be doing fillet welds, which is exactly what you do when you weld T-joints. Here, we're welding on a groove, so we call it groove welds. So here are our positions. Know them, memorize them. If I ever ask you what position you're working on, I expect you to give me the 1G, 2G, right? Things like that. Don't throw, hands, I'm working on horizontal here. No, tell me what that position is called. That very first day when you come in, right off the back, we're not working on bead pads or anything. We're going to start welding on an actual piece of plate. And so the first position that you're going to be working on is the 1G position, which looks just like this. We consider that to be the flat position. When you do set it up inside of your booth, make sure it's about waist high. Do not have it like way up here to your chest area. You're not going to be able to see very well. So have it around your waist, and you should be good after that. And of course, once you go in there, ask me, hey, how should I position myself and things like that. I can't tell you how to position yourself through the camera, obviously, and so that's something that we're gonna have to work on one-on-one. But for at least I want you to know where the plate needs to be positioned. So before we even start working on those plates, however, those pieces aren't going to be pre-cut for you. You will have to cut them on your own using an oxyfuel cutting torch and what we call a track burner. And so when it comes to this track burner, again, I can't quite show you as to how to use it while we're here online. It's going to be a lot better if I just take the whole class and crowd you guys around this track burner, and then I'll show you guys exactly how to use it. But for now, just so that you have a quick overview as to how we're going to use it, here is just a basic picture of what the top of this track burner looks like. We really only have two controls, so it's not very complicated at all. With this control here, you can see there's a turtle on this side and there's a rabbit on the other side. That just basically means that when you have it over here along the turtle side, it's gonna move slowly. This track burner is meant for you to have it on, and then it just moves along a track. And so as it's moving, it's going to be cutting that piece of bevel for you. And so it's because there's not going to be anything shaking it, right? And us ourselves as humans, we tend to shake as we're cutting something. However, if we have this mechanized, it's going to create a real nice smooth bevel for you. And so that's why we have to use this. But anyways, when you are cutting with the track burner, this speed needs to be set at around 12 or 11, somewhere along there. And so it might be a little hard to see the numbers from your screen. However, here we could say it goes up in increments of 10. So 10, 20, 30, 40, 50, etc. You want to have it about 11 to 12 on the speed. That's this knob here. This one just basically controls the direction that the track burner is moving, right? We're gonna have a real long rail, and within that rail, we're gonna have this track burner moving side to side. And so when this knob is in the center, it means it's stationary. It's not moving anywhere. If it's to the left, then it's gonna be moving to the left. If it's to the right, then it's moving to the right. And it's really that simple. As far as how you're gonna turn on the torch, it's exactly the same way that you've turned on the torch in your intro class. So nothing changes at all in there. Once you're done using it, you're going to have a real long strip. With the strip, you're going to cut that strip into 6-inch long sections with the oxyfuel cutting torch. And so that's how you're going to acquire your coupons. After you have your coupons, you will have something that looks like this. So we have one coupon here, we have another one there. Again, we put a bevel on it. Aside from these two coupons, we still have to cut our backing strip, which these should be quite familiar to you because you use these same pieces of flat bar to make your T joints in your intro class. And so it's the exact same thing. You're still going to clean them. However, you're not going to clean it on both sides of that backing strip. You only need to clean one side. So just keep that in mind. As far as your coupons, you don't have to clean up the whole surface. You simply have to clean up about 1 inch along the top side on where the bevel is at, where that smooth bevel is at, and then about 1 inch on the bottom side. I know you can't see that in this picture, but just like it's cleaned up here on top, it's also cleaned up down here at the bottom. And you also have to clean up that bevel. When you're using your grinding disc to clean these coupons up, make sure that you don't damage the edges. So for example, we could see there's a real nice sharp edge all along these edges here, and then of course the very edge of this is also really nice and sharp. Again, try not to damage that. Keep that as original as you can. The way that you're gonna set these two pieces of bevel plate up is that you're gonna lay these upside down inside of your booth. And so right now they're right side up because the bevel is facing upward. And so if we flip them upside down, we're going to keep them there. And then we have to space these 1/4 of an inch apart. And so again, that's something that you should probably write down. Your root opening for backing strips, for coupons that have a backing strip, it need to be 1/4 of an inch apart. And so what can we use in order to have that correct spacing? Think about it. What can we use? Your backing strip. And so if you look at this backing strip, that's 1/4 of an inch thick. That's what you're going to want to use. And I'm actually getting a little bit ahead of myself here. Before I move on, one thing that I want to point out is that I did mention earlier that we are going to cut these 6 inches long. When it comes to this backing strip, cut that 7 inches long. The reason I want you to do that is so that part of that backing strip comes out here on this side, and then same thing on this side. And of course, if the backing strip is 1 inch longer than your coupons, then it's going to be protruding out about 1/2 an inch. So do that before we actually start welding or spacing it apart or anything like that. So once you have these two pieces of plate upside down inside your booth, you're going to use that backing strip, put it right down the center so that you could create a 1/4 inch spacing right in between these. After that, you're going to remove your backing strip, and then you're just going to lay it down flat on the back end of the two coupons, just like we have here on this picture, right? And again, we can't see the bevel because remember that bevel is right here in the center. We're going to be covering it up with that backing strip. And also, remember, we only cleaned one side of that backing strip. That clean side needs to be going face down. So just keep that in mind. Once you have that ready and you know that your backing strip is really nice and centered, then we're going to put our tacks on this coupon here. And so you're going to set your control box to about 30 to 35, which is roughly about 70 amps. So it's not very hot. However, it's something that I want you to do because later on when you move on to open root, you're going to have to run your root pass at this exact temperature. Now, can you do these tacks at, let's say, 50 on your control box? Yeah, absolutely, you can. And it's going to be a lot easier if you do that. However, if you get used to always welding at a hot temperature, when it comes time for you to weld at this low temperature, doing that root pass a little bit later on, you're going to have a very hard time even striking an arc at this temperature. And so that way we don't forget as to how to weld at a low temperature. This is the reason that I have you doing these tacks at such a low temperature. So just keep that in mind. You're going to grab a 6010 rod, and then you're going to place your tacks on here. You're going to have 3 tacks on each side of this plate. So you're going to have one here, here, and here. Each of these tacks need to be about 1 inch to ½ an inch long. So they're not going to be very, very big, but just again, make sure that you have your fit up correctly. Now, when we are doing these tacks, what is the correct sequence in which we should put these tacks? Should we just do one side at a time, or how are you going to tackle this? What I would suggest you do is, for one, do not ever put all the tacks on one side, in sequence. Because if you just tack here, then you tack there, then you tack there, what's going to happen is that this piece of plate is going to rise up, and so when you try to tack it on this side, you're going to have a huge gap. It is very, very important that when we're welding with the backing strip, that backing strip is laying down flat up against both pieces of plate. And so you want to sequence these tacks to where that doesn't happen, to where you can minimize that. And so what I would suggest you do is, again, don't tack both of them on one side, because if you do that, then this plate, instead of it rising side to side, it's going to rise like this. Because if the tacks are on this side, then obviously both tacks are going to pull it up, and it's going to be hard for you to tack it on that side. Is it possible if you use pliers and stuff like that? Yeah, you can, but let's get used to welding in the correct sequence. So what I would do, if you're going to weld on this tack first, on this corner first, I should say, then the next one that you should do should be not only the opposite side, but also on the I guess both opposite sides is how we could say it, right? So you do it here, and then boom, you do it right over there. And then after that, it doesn't quite matter what you do next. Just do the middle ones last if you need to. After that, you could do this, and then you can do that, right? So just kind of stagger them to where you're not creating more stress on one side as opposed to the other. The technique that you're going to use in order to put these tacks down is just simply a whipping technique. So exactly like how you ran your root pass in your intro class with that real nice tight whipping technique, 60-10, that's exactly how you're going to do it here. And so again, just to give you an illustration, see if I can make this work. Your tacks, right? If we're looking at this plate from a different angle now, with this being your backing strip, your tacks should look real nice and flat, just like this. That's exactly how your tacks should be. If your tacks are coming out a little bit differently, so for example, if they're coming out something like this is what we call code lap. You're code lapped on this side. Anytime you're laying down any sort of weld, whether it's a tack or whatever it may be, there needs to be a smooth transition from our base metal to our tack, right? This is a fairly smooth transition. Same thing on this side. However, yes, it's a smooth transition on this side. However, boom, right? It's real jagged around that side, and so we never ever want that. And so make sure that when you place your tacks, they don't have too much what we call convexity, which is that belly. We also don't want our welds to be this way, concave. We don't want them concave either. Have them as flat as you can. And in order to accomplish this, you're going to have a bit of a skill to do that, because you can't go too slow, but you also can't go too fast. You have to go just at that right speed. And if you start having trouble with any of these tacks, feel free to come get me, and I don't mind going in there, welding for you a little bit, and showing you the proper way of doing things. So Here's another example as to what I was saying earlier about that backing strip lifting up, about how important it is for that backing strip to always lay down flat against both plates. And so in this example, it's somewhat flat up against this plate. Let me get my laser on here. It's somewhat flat up against this side. However, if we take a look at this side, see how it's lifted up just a bit? And so as you could see, there's all sorts of trash and inclusion and slag inside of this part here. And that trash is coming both from the tacks that were done and also from that root pass that we'll talk about a little bit later on that was done as well. And so again, always keep that backing plate as flat as you can up against that bevel plate. It's very, very, very important. And so let's go over the different parts of the of backing strip welds. In this particular illustration, there is no backing strip, as you could see, right? And I'll go ahead and kind of draw it on there for you. So boom, now we have a backing strip. But our root pass, just like on your T-joints, is your very first pass. So that root pass is going to be somewhere down here along this area. After that, we have our hot pass. Goes there. Our fillers, we're going to have multiple fillers. So it's not just one, it's not just two. You're going to run as many fillers as you need to in order to fill this piece of bevel plate up. I know that when you're welding those T-joints, you didn't really have a place where you could say, okay, this is enough, I'm good to go. With bevel plate, because you do end up filling up this groove weld, this top side, that's your goal. That's where you need to get. And so fillers is going to be all of this right here. And it could be any number of fillers. After that, your cap is your very last pass. With the cap, the difference between a filler and a cap is that the cap actually extends over this base metal. And so this would be the example of a cap here. All of this area, right? All of that there. And so this is just kind of illustration because as I'm going through this, I will refer to the root, hot pass, fillers, cap, things like that. And I really want you to know the terminology of things as I'm going through it. Before we get into that, however, I want to go over some of the basics of welding. Again, I know that you have already welded in your intro class. However, I just a quick run through just so that we all know that we're all on the same page. And so let's talk about amperage. How do you know whether you're welding at a low amperage or if you're welding way too hot? And so we know that the easiest way to see that is by simply looking at our weld puddle. In this example here, you could see how big the rod is as opposed to the actual weld puddle that we have there. That weld puddle is way too small. You at least want your weld puddle to be maybe about 3 times bigger than this. On the opposite end, if you're welding too hot, you're going to have that weld puddle being way too big. Notice that in this illustration, you can kind of barely tell where the edges of the weld is at. So your edges are about somewhere in there, it looks like, of the actual bead itself. And so notice the weld puddle is just as wide and big as the bead itself. You never want that to happen. In this particular example, if we wanted a good weld puddle, that puddle should be somewhere along the lines, maybe like this. I'm not sure what this is, ignore that. But notice how if we have it this way, it's not nearly as big. It's maybe like 2/3 the size of the width of that bead. And so that's kind of the ideal puddle size that we're going to be looking for. What else? Let's talk about rod angle. When we're welding with stick, what is the proper rod angle that you should have? We know that we should always have what's called a drag angle. Drag angle means, so I'll show you an example here. Let's just say that this is just a piece of bevel plate. When we're welding, if we want to start on this side, how should we be angling this rod? This rod, in order to have a drag angle, we need to be pointing the front of it to our starting position. So as we're moving like this, notice how the front of that rod is always pointing towards our starting position. That's our drag angle. You never want to be pointing away from your starting position. So for example, this way. You never want to be pointing the rod this way because now you have a push angle. The only position in which you use a push angle to weld stick is the vertical position, because we start off like this, as you guys could recall from your T-joints. Notice how we're pointing away, right? This is our starting position. We're pointing away from that starting position. And so that's the only time we use a push angle, but you always need to be using a drag angle. Now, you could have a bit of a different drag angles, and so we could have a drag angle like this to where it's just barely kind of tilted, or we could have one that's really inclined. The way that you make a decision as to which one is appropriate is, well, depending on what you're trying to do. And so when you have a straight up and down drag angle like they do here, you don't want to have it straight up and down, simply because with stick, as we're welding, we know that this electrode, it's depositing not only metal but slag as well. And so if that rod is like this, it's going to deposit slag all the way around. Now, the issue with that is that whether we're moving this way or that way, you're going to be running over your own slag, and that's when you tend to get a lot of porosity. And so that's the main reason why we have to use a drag angle, because if we do it this way, because the rod is pointing that way, you're going to always be pushing that slag away from your direction of travel. So if we're traveling that way, we're pointing this way, so the slag is going this way, and we're not going to be running over our own slag. However, you can't have too much of a drastic angle like this, because if you do, this will happen. Just like in this illustration, see how that puddle tends to get real elongated like that? And what tends to happen, if you have a elongated puddle like this, your bead will crown up quite a bit down the center. And so the more you start angling your rod this way, the flatter and more even that your bead is going to be. And so that's why we want to have a drag angle somewhere in between, not completely straight, but not way too much. Somewhere in between there, which will end up being about 10 to 15 degrees is the ideal. So what about travel speed? How do we know if we're going too fast or too slow? Well, if you're going too slow, you're going to notice that your puddle is going to get bigger and bigger. So even if you're welding at the correct amperage, if you go too slow, you're going to be building up a lot of heat in that area, because again, you're just barely moving, so a lot of heat is being built up. And so even though you have the right amperage, it's going to feel like you're welding at a much higher amperage because of the heat input that you're putting in there. So you don't want to move too slow. Again, if you do move too slow, you'll notice your puddle starts to get a little on the big side. If you move too fast, of course your puddle's going to start shrinking, and so it'll look a little bit more like this. And notice, not only does it start shrinking, it'll start elongated. And remember, anytime we have an elongated puddle like this, that's going to cause our bead to crown up down the center quite a bit. And remember, for example, if we're drawing our bevel plate there, and if that bead is crowned up like this, right? Is that a smooth transition from our base metal to our weld? No, right? We need this bead not to crown up so high like this. We need it to flatten down. And so you don't want to go too fast. You want to go, again, somewhere in between. So always keep that in mind. Last but not least, we have the arc gap. Our arc gap is the distance that this rod is sitting away from our base metal. And so anytime we're welding, we always want to have what's called a tight arc gap, meaning that this rod is extremely close to that piece of metal without actually touching it. You never want to do what's called long arcing. Long arcing means that you're pulling up that rod too much. And so you want to always keep a tight arc, similar to what this illustration says here. The reason you don't want a long arc, there's quite a few reasons. One, you start getting a lot of defects, such as undercut. What could also happen is that because you're so far away from the plate, you might get some porosity because that flux coming off of the rod is not protecting our weld properly. And so you always want to keep it as tight as possible. Not only that, but as you start pulling up, you actually start increasing the heat input that you're putting into the piece of plate. And so later on that could lead, it might not be a problem perhaps if you do it like on the first pass, but after you start welding on this piece of plate and you have a lot of passes on there, by then it's probably already hot, and then by you long arcing it, you're going to put even more heat, and that's going to make it difficult for you to actually finish out the weld properly. And so you definitely don't want to be long arcing. Keep a always tight arc as short as you can keep it. All right, so moving on here to our root pass. So by this point, we already have our tacks. We have a total of 3 tacks on each side. Of course, because we're looking at it from the side, we could only see these 2, but we already have the tacks there. Now that we're ready to weld, you're going to put your control box at 50, which is roughly about 100 to 110 amps. Once you have your control box set, you're going to grab a 7018 rod, and you're going to be running your very first pass on this groove. This very first pass, remember the root pass goes right in here. That's how we want the root pass to look. Make sure that you're tying into the walls properly, and then also make sure that when you do finish this root pass, make sure you clean it up, completely remove 100% of the any slag that might have been left behind, and that's the ideal root pass there. Now, because you're at the very bottom of this groove, are you going to be able to go side to side very much? Probably not, right? So you're not going to be running a weave bead. It's going to be more of a stringer bead. So keep that in mind, meaning that you are going to be moving side to side, but man, just slightly. It's not something that you're really going to be swinging out from wall to wall. And as you're doing this root pass, just like on your T-joints, make sure you're tying into both walls properly as you're doing it. Now here's an example of something that I don't want you to do, or in case maybe your bead does come out looking like this, I want you to know how to be able to fix that. And so let's just say you run your root pass and your root pass comes out like this, right? It's crowned up down the center. If you have your bead looking like this, a lot of the times you're going to be trapping a lot of slag on each side, on this side. So that's why when you do run your root pass, I want you to keep it as flat as possible. And of course, you also don't want the opposite, to where your bead is concave either, which is, you know, it's caved in on itself. You want it flat. If you don't have a good foundation with your root pass here, guess what? The other beads that you're laying on top of it, they're also going to come out bad, because again, the foundation is off. It's very similar to a home. And so keep that root pass as flat as you can. If you're having trouble with that, again, come get me. We'll go inside your booth. I'll watch you weld, or I could actually weld for you as well, right? Don't be shy about asking me to weld. I don't mind doing that at all. But we need to get that root pass to look nice and flat. After we're done with the root pass, let's just say here that we have completed it. Uh-oh. Give me 1 second. Right, boom, there it is. There's our root pass. After the root pass, we're going to run the hot pass. Hot pass is also going to be done with a 7018 rod. Notice the temperature is exactly the same. And as I'm going through each pass on your notebook, you want to do the same thing. Write down root pass, and then write down all the parameters that you need to meet. Write down hot pass, write down all the parameters you need to meet on that as well. And so once we start this hot pass, notice again, it's still not very wide. And so chances are it's still going to be more or less of a stringer bead. So is there really any difference between the hot pass and the root pass in this particular situation? Not really. The only difference is that the hot pass is going to be a bit wider. And again, common sense, right? We're going up as we go higher and higher up on that bevel. You notice the distance in the center gets a lot wider, and so your bead is also going to be wider. So it's just about the same. You're still looking for the same thing. Your goal is still to keep the bead as flat as you could get it. Moving on to the fillers. Fillers, again, same thing. 50 on your control box. You're still using a 7018. However, remember that when it comes to fillers, we don't just have one filler or two fillers. we're gonna have a good number of fillers on there. And again, your neighbor may lay down 7 fillers and you may lay down 5 fillers, but yet you guys are still, as long as you fill up all the way to the top, it doesn't really matter the number of fillers. It just kind of depends on whether you're going a little bit faster or a little bit slower. My suggestion would be to run all these fillers a little on the fast side. You want to pause as you're going side to side on your edges. However, you don't want to sit there and pause too much to where you're building up too much at once, because at that point you're going to be carrying a lot of metal every time you're going. And so yes, you're filling it up a little bit quicker, but you're making things a bit on the harder side for yourself. So don't do that either. Now maybe let's just say the first 2 fillers that we lay down, there's still going to be more or less stringer beads. You're going to be moving your rod side to side, but not a whole lot. And so let's just say, boom, that's it right there. That's our filler. That's one of our fillers. As you start building up more, you're going to get to a point to where the distance between this bevel and the other opposite bevel is going to be a little on the wide side. And so by code, we're not going to be able to run a bead that's that big. So eventually you will have to start laying down 2 bead fillers. And so what a 2 bead filler is for example, the general rule that I want you to follow when you do run 2 bead fillers is basically when you run your first bead, run it about 75% of the way. So if we look at this distance here, 75% of this distance is about here. So we're going to start here, and then we run a bead this way. That's going to be our first bead. For our second bead, on this one, you don't have to go 75% of the way. This one, you only go about 50%. So it'll start about here, and then it'll, boom, tie in all over there on that side. And ideally, by the time you're done making these beads, you should, again, it should look as flat as you could get it. Make sure that you don't have a valley in between these beads. If you do have a valley in between these beads here, it means that you didn't overlap them enough. You need to overlap them on top of each other just a little bit more than what you did before. And of course, if it does end up real crowned up down the center, it means you overlap them too much. So you need to find that nice medium in between there. Because we're working on 1G, I don't ever want you to do 3 bead fillers. So only a maximum of a 2 bead fillers when it comes to 1G. The only time you do 3 bead fillers is when you get to 2G, which is the horizontal position. However, when we get to that, I'll talk to you kind of one-on-one as to what you have to do with that. So for now, let's just focus more on this 1G position just to get you started. And one other thing to add is that once you do start your 2 bead filler, you have to maintain that 2 bead filler all the way to the top. And so what I mean by that is that, let's just say we did start our 2 bead filler here. After that, you can't just decide, yeah, you know what, I'm gonna go back to doing 1 bead. No, you have to maintain 2 bead fillers all the way through. Also, it doesn't matter which one you do first. Keep that in mind. So if we wanted to, we could have done the first one on this side and then the second one over on this side. The only time the sequence of your beads matter is when you're on a 2G position. With 2G, you always do the bottom bead first and then the top. If you're doing a 3 bead filler, then it's going to be the bottom one, middle one, and then the top. But don't ever start from top and then go bottom. It's always bottom to top. Keep that in mind. And so now that we started our 2 bead, again, just kind of maintain that 2 bead all the way to the top. So in this particular scenario, let's just say that we finished up our bead. I know it's a little crooked, but let's pretend it's nice and straight and flush. When you do your very last filler, make sure that you do not go over this edge. Do not go over this edge right here. Always keep this edge as sharp as you could get it. Remember initially when I asked you to grind these pieces of bevel plate, I was real big on not damaging that nice sharp edge that you have with the bevel. And so this is the reason why. Because if you do damage this edge, for example, either your bead goes over it or you damaged it with the grinder, when it comes to the next pass, you're gonna have a whole lot of trouble. And so again, just we'll get to that here in a bit, but so just keep them as flush as you can get it. And again, when you do that last filler, make sure you're not overfilling it. Your fillers need to maintain inside the bevel. So this is an example. I know this is just a 1 bead filler, but it should be more or less the same when you do have your 2 bead fillers. Try to keep it looking like this, nice and flat. Again, notice you don't necessarily need a real tight bead pattern as well. You could kind of open it up just like they have it here. But again, stay inside of your bevel. Do not go outside. If we really wanted to nitpick this particular weld, we could see here that they actually came out a little bit. So this would be an example of undercut, right? Because our edge, we could clearly see where our edge is at, and they accidentally just kind of bit into the to that edge there. So again, try to minimize that as much as you can. If you're able to do that, this last pass that's called the cap is going to be a lot easier for you. So we have our root here, we have our hot pass, and then we have our 2 bead filler here, right? Let's pretend this is a 2 bead filler. So now we're ready to go ahead and cap it. The cap is going to go like this. The cap is the only pass that actually extends outside of that sharp edge that we were talking about. So your cap will end up starting here, and then on this side, it'll start a little bit over that edge. The main purpose of this pass is to just basically seal our weld in. Everything that we've done before, we're just sealing it in. You are going to have your control box at 50, just like you've been doing with all the other passes. You're going to grab your 7018 electrode, just like you've been doing with your other passes, and then you're going to run weave beads here. The reason you can't run stringers is because, remember, stringer beads are beads in which you just barely moving your rod side to side. In this case, we're not doing that because now by this point, I mean, look how wide our bevel distance is here. And so we are going to have to move a bit on the side. You're going to be pausing on each end as you're moving side to side as well. Also, this is 1G, and so like I said earlier, we're never going to do a 3 bead anywhere. Not only are we not going to do it during our fillers, but we're not going to do it during our cap either. So your cap will also be a 2 bead cap. And so again, it doesn't matter which side you do first. For example, on this particular example, I'll go ahead and do the other side here first, but you always need to follow that rule of when you run the first bead, that's going to be about 75% of the way. And so it's going to look something like this. And again, we're just kind of barely extending outside of that edge. Just if you're wondering by how much amount you need to extend over the edge, as long as you cover up that edge, that's going to be sufficient. So even if it's just a hair over that edge, as long as you're covering it up, you're good to go. So this 75, and then the other one's more or less about 50% of the way. In this particular example, you could see that there is a little bit of a valley down the center, right? It's not completely real nice and flush as it should. Obviously, that's my drawing isn't very good on here, but let's kind of make the best of it here. Let me give you an example of what overlap looks like. This is a defect called overlap, or it's a discontinuity, I should say. And so anytime you have a valley in between your beads here, it usually means that we didn't overlap our beads enough. In this case, we still followed our 75-50 rule. However, the reason we still have a valley here is because when we ran this first bead, notice how it's inconsistent. It looks like possibly we could have paused here a little bit more than what we paused here. And we could see that because this is a much higher, right? We have more metal there as opposed to, look at this height. It's a lot less. And so that would probably indicate that we're pausing inconsistently on both sides. And so that's what your cap is. And again, write this down as well. 1G is a 2-bead cap, 3G is a 2-bead cap, and 4G is a 2-bead cap as well. The only positions that are going to have a 3-bead cap are 2G or 4G. Now, you might be asking, well, wait a minute, you said 4G is a 2-bead cap. Well, when it comes to 4G, I'm going to give you an option as to whether you want to do a 2-bead cap or a 3-bead cap. The reason I'm doing that is because when you're out in the field, a lot of the times you will be given options. Most times they will tell you, hey, I only want a 2, I'll only put a 2-bead cap on that, or put a 4-bead, whatever it may be. So I kind of want you to get used to making a little bit of that decision for yourself. So when it comes to 4G, you choose whether you want a 2 or a 3. One of the last things that I want to cover here are weld defects. Again, this should be a bit more of a review more than anything, but when it comes to your cap, know that the maximum reinforcement you could have on your cap, meaning the distance between the base metal and the highest point on your bead, so this distance here, that can be no more than 1/8 of an inch. So again, write that down if you need to. The maximum reinforcement of your cap can only be a maximum of 1/8 of an inch. If your cap is over 1/8 of an inch, then you're going against code. You're going to fail whatever test that it is that you're testing for when you are going out there and getting a job. And of course, I'll be taking off points for that if you're over that 8. So keep your cap over 0, meaning it has to be higher than the base metal, but it can't be over 1/8. So that's a little bit of a tricky situation. You have to make sure you're not going too slow as you're doing that cap. An easy way in which you could measure whether you are over 1/8 or not is by simply using a 60-10 rod. Remember the 60-10 rod that you use there at San Jack, that's a 1/8 rod. And so you could use that to measure whether you're over or not. Next up, we have underfill. If you run your cap and part of your cap is under your base metal here, meaning that it's lower than the height of your base metal, like we do have here, that's what we call underfill. Don't confuse that with undercut. Undercut is a little bit different. Undercut means that you're gouging in on the toes of your welds. Whenever we refer to the toes of your welds, we're referring to the edges. And so this would be an example of undercut. A lot of the times you get that simply because you might not be pausing on the edges enough, or it could be that you're running too hot. It could be that you're long arcing. Basically everything tends to cause undercut, or most things anyways. And so again, if you're having issues with any of these discontinuities, come get me so that way we could solve that situation, and so that way we could prevent you from getting those anymore. And then we have excessive reinforcement. Clearly we could see here this is way over 1/8, right? So if we're going by the same dimensions here, 1/8 is about somewhere along this area here. And so we're way over that limit, and so this is what we call excessive reinforcement. Overlap is when you don't have a smooth transition from your base metal over to your weld. Like here, it's not too bad. It has a little bit of overlap, but it's not too bad. But here, we could clearly tell, right? This is our base metal. We're basically, boom, going up vertical, right up against that. And so it needs to be of a smoother transition. That's on a T-joint. Same thing could happen on a piece of bevel plate. Again, nice smooth surface here, smooth transition, not bad. But then it's almost like we go from flat to almost completely vertical here in this situation. So that's what we call overlap. Again, a little bit of the same, right? Excessive reinforcement. Overlap could also happen when you're overlapping your bead. So in this case, it looks like they did a 2-bead cap here. So let me go ahead and outline that real quick. So we could see again, there's a little bit of a valley in between those two beads. Ideally, we want the beads to look something like this, to where it's just a smooth. Looking at it from the side, it should only look like you did with 1 bead, although you did a 2, right? So in this case, a good one would be something like this, and then here's a second bead, right? Something along those lines. Same thing, underfill, right? So again, if we're below the base metal height here, in this case, it's a little harder to see in the illustration, but let's just say that it was going this way like this. Right, clearly this is a little bit below the base metal height, so there's that. Lack of fusion, That's also something that you need to worry about, not so much in your cap, but typically it'll happen during your fillers or your hop pass or even your root pass. And that's typically when you're not tying into the edges enough. That's why it's very important that as you're filling this up, again, always try to maintain a flat bead. If your beads are coming out like this, that's going to lead to lack of fusion eventually. And so if your bead does come out like this, simply go outside, grab your grinder, and grind that down to where you have a nice flat foundation, so that the passes that follow, they'll also have a nice flat foundation to lay up on, and it's going to make things a lot easier for you in the long run. Last but not least, I want to show you guys a picture of what it looks like to overlap beads. So I know before it was just kind of illustrations of what I wanted it to look like, but this is a real life kind of demonstration there. This is a 2G piece of plate. As you can see, remember we said we're going to do a 3 bead cap on it. And so we could tell that we do have 3 beads, 1, 2, and 3. Initially, you could see that I know it's a little dark, it's hard to tell, but they started with a 1 bead for the root. Their hop pass was also a 1 bead. And then once they started their fillers, you have an option of if you want to start with a 1 bead or a 2 bead. In this case, it looks like they started with a 2 bead right away. Here's one, here's the other. And then after that, you could see that they opted to go ahead and instead of running another 2 bead filler, they went ahead and started running 3 bead fillers. And they just kept doing that until they got to their cap, which again is also a 3 bead. Also, this is a good illustration as to how much over the edge you should be going. And so we could clearly see the edge of our plate here, right, somewhere along those lines. And we can see it. I mean, that cap is just barely going over that edge, right? So make sure that when you do your cap, don't go crazy and go way down here just to tie in. Just as long as you cover up that edge when you do your cap, that's as far as you need to go. So keep that in mind. If you have any questions over any of this while we're in class, again, approach me. I'm very approachable. I help you out whatever it is that you need. You just need to communicate with me. But that's all I have for you guys today. And good luck out there. I hope to see you soon.